Kusum ma'am. So yeah, in your recent comments, I found like you are feeling very difficulty in quadrilaterals chapter. So yeah, if you are tensed with quadrilateral, this is how we are going to solve it. Okay, so let's start out with that. What do you mean by quadrilateral? Already in your lower standards, you came across with quadrilaterals. So prior to this quadrilaterals learning, you should know the properties, and those who did chapter number 7, similarities of triangle, very nicely, they will get it very easily. So here, as I told you, like this chapter is fully based on the concept which you did in chapter number 7. If you are clear enough with your quadrilateral triangle, similarities of triangle, so this will be very easy to get through. What do you mean by quadrilateral? So let's start out with that. So a quadrilateral is a closed figure. Quadrilateral is a closed figure which is made up of 4 lines. So here, so let's start out with the thing. So here in quadrilateral, it's a closed figure which is made up of 4 sides. Quadrilaterals are of different types, as you already know. So quadrilateral can be like rectangle, it can be parallelogram, it can be rhombus, it can be trapezium. So like we have different types of quadrilateral. So when it is only about quadrilateral, means nothing special is given, only 4 sides closed figure. When the figure is with 4 sides, we call it as quadrilateral. So today, as it was decided, we are going to start out 8.1. In 8.1, first question, it is given if the diagonals of parallelogram are equal, prove that it is a rectangle. So here it is parallelogram. So what do you mean by parallelogram? Parallelogram is a figure where opposite sides are parallel. So here these two sides are parallel and these two opposite sides are parallel. Let ABCD be a parallelogram. So whenever you are going to start out with chapter number 6, 7, 8 or 9 or 10, all those are like chapters based on trigonometry. So in these chapters, we need to start out with given to prove, though if your solution is wrong, if all these things which you are filling out from the question, all these carries marks. So generally these questions are asked for 4 marks. And if you are clear with the things, so first you learn what you can write out as a given to prove. Later on you can move out with the remaining part. And if chapter 7 is clear, similarities of triangle is clear to you, you can easily go through with this chapter as I told earlier. So let's move out. Here in the question it was given if the diagonals of parallelogram are equal. So here it is given ABCD is a parallelogram. So here this is the symbol of parallelogram. In short, you can write like 2 lines and then GM. So here ABCD is a parallelogram, and then we need to prove that it is a rectangle. So to prove ABCD is a rectangle. So this we need to prove. So given and to prove and diagram. These 3 are the important parts which you need to start out. You need to write what is given, the figure you are going to draw as per the question, given and to prove. So let's move with proof part now. So here in proof part, if we draw AC, if we join AC, so here this will be in construction. So in construction, make the line like draw AC or join AC. In proof, here we are getting 2 triangles. In triangle ABC and triangle ADC. As we have 2 triangles, so we'll start out with that. In triangle ABC and triangle ADC. So what points we are having? If you recall back similarities of triangle, as I told you, we need to use all those points here. So here the first point, AB is equal to CD. First point, AB is equal to CD. Second point, AD is equal to BC. So how we got these equal? These are opposite sides of parallelogram. So here you need to write the condition. Opposite sides of parallelogram are equal. So this we got from there. Opposite sides of parallelogram are equal. Now the third point, AC is equal to AC. That is, AC is common in both the triangles. AC is common. So this is common side. Once again repeating, AB and CD both are equal. So how we got AB and CD equal? They are opposite sides of parallelogram. And the same way, AD and BC are equal. They are also opposite sides of parallelogram. And the third one, AC is common. So here, AB and CD we got. They are opposite sides of parallelogram. AD and BC opposite sides of parallelogram. AC is common. When we get 3 points, we can make the triangle to be congruent. So both the triangles are congruent. Therefore, ABC is congruent to triangle ADC. So here, when the triangle got congruent, their corresponding parts will be equal. So here, to make it rectangle, we need to make adjacent sides, adjacent angles to be equal. Or like we can make it 90. So now here, once the triangle is congruent, we can make angle D equal to angle B by CPCT. See here you need to concentrate properly. Here I have chosen ABC, ADC. So here D is not there in this part. You should not take D here. As per the triangle only, angles to be taken. So here angle B will be equal to D. This is by CPCT. That is congruent parts of corresponding triangles. Now once angles got equal, we can make them like x. So let's consider B equal to D equal to x. Moreover, in parallelogram, so your opposite angles are equal. This we proved also. It was given like parallelogram. So here we need to make it 90. So now x plus x is equal to 180. See here, prior to this, one more thing we can do, like instead of here we consider these two triangles. So instead of that, if we take the triangles in this way, like if this triangle and this triangle we will choose, that's the better way we can make the triangle to be congruent. So here choose these two triangles. Once again, like A, B, C, D. If I'll take triangle A, B, D and triangle A, B, C. So first point, AD will be equal to BC. Second point, AB common in them. AB is equal to EB, common side. And third point, BD is equal to AC. The diagonals of parallelogram are equal. Diagonals of parallelogram are equal. So in this way also we can make the triangle congruent. So this is the better way compared to this. Here we need to go for one more step if we make the alternate triangles. So here we made the adjacent triangles to be equal. Now angle A is equal to angle B. This is by CPCT. So once again I am repeating the part which I took. So I took this triangle and this triangle where AD and BC are equal. They are opposite sides of parallelogram. AB is common in both the triangles. Third part, diagonals are equal. BD and EC, they are the diagonals of parallelogram which are equal. So here we got both the triangles are equal. So here when the angles are equal, we can make them equal to x. So here x plus x is equal to 180. How we got these two x to be 180? They are adjacent angles of parallelogram. Sum of adjacent angles of parallelogram is supplementary. So we can make it 180. So here x plus x is 180. Adjacent angles of parallelogram are supplementary. That is 180. So twice of x is 180. So x is 180 upon 2. Thus it is 90. Here we made one of the angle to be 90. Similarly, we can make all angles to be 90. Parallelogram with all angles 90 is considered as rectangle. So here I will write similarly angle A equal to angle B equal to angle C equal to angle D equal to 90. Therefore, ABCD is a rectangle. So this is what we need to prove. Repeating once again, so those who joined now, they can see this. So let's repeat it once more. Here ABCD was given quadrilateral. So here ABCD is a parallelogram, it was given. We need to make ABCD to be rectangle. So here given ABCD is a quadrilateral. This is symbol of quadrilateral. To prove ABCD is a rectangle, this we need to prove. Now in construction, what we did in construction? We joined BD and AC. So this is the construction part. Join AC and BD. Now let's start out with the proof. Okay, some of you commented like it is a orthogonal. It's not a orthogonal. So we are discussing with the quadrilateral part. It's quadrilateral only. Now AC and BD both are diagonal. So let's move out with the proof part now. Now in proof, we'll consider two triangles. Earlier, like in 7th chapter, you did the similarities of triangle. The same property we are going to use here. Here two triangles are there, ABD. In triangle ABD and triangle, here I have taken ABD. So this triangle ABC. Triangle ABC. Two triangles we have chosen. Now the first point, AD. In triangle ABD, AD is equal to AC. They are opposite sides of AD and BC are equal. AD equal to BC, opposite sides of parallelogram. Second point, AB is equal to AB. It's common side. So it's common. That's the second point. Third point, here we have taken ABD triangle. So BD is equal to AC. They are diagonals. Diagonals of parallelogram are equal. So this is what we made, both the triangles to be congruent. Therefore, triangle ABD congruent to triangle ABC. This we made by side, 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 SSS. Once the triangle is congruent, their corresponding paths will be equal. Therefore, angle out of this triangle, angle A and angle B. Angle A is congruent to angle B. This we got by CPCT. Once we make the triangle congruent, we can make the angles to be equal. So angle A and B is equal by CPCT. Let we'll consider that to be X. Angle A equal to angle B is equal to X. Let it be. Moreover, if we add them, X plus X is 180. Here the reason will be adjacent angles of quadrilateral are supplementary. So in that sense, twice of X is 180. So X is 180 upon 2, 90. Once we made the angle to be 90, similarly we can make rest of the angles to be 90. So here, if a quadrilateral is there with all angles 90, it is a rectangle. How we can make it to be square? Here the same question they ask in different way. The first case they can ask, prove that it is a rectangle, or they can ask, prove it to be square. If they will ask for rectangle and it is given parallelogram, the sum will get over. Once we made it 90, we can make it to be rectangle. If they will ask it to make it square, we need to make all the four sides equal. So there the sum will proceed furthermore. So here our first question got completed. Similarly, we can make prove angle A, angle B, angle C and angle D to be 90. Therefore, ABCD, quadrilateral ABCD is a rectangle. So this is our first question got completed. Let's move on with the second question. Now here in second question, it is asked, show that the diagonal of the square are equal and bisect each other. We need to prove that diagonals of square are equal. So here it's given ABCD is a square. Question number 2, ABCD is a square. Here in given quadrilateral ABCD is a square. We need to prove, read the question and fill out this given and to prove. Here it is, we need to prove diagonals of the square are equal and they bisect each other at right angle. So here the diagonal is AC and BD. The second part, in to prove, we need to make AC equal to BD. And moreover, they bisect each other. So what do you mean by bisect? Means they are dividing each other in equal part. That is, if they bisect at O, OA will be equal to OC, OD will be equal to OB. They are bisecting each other, that we need to prove at right angle. So here totally 3 things we need to prove. The first one, we need to make it square. The second one, we need to make diagonals equal. And the third one, we need to make that they are bisecting each other at right angle. So for this kind of question, as it is given, first we need to make it square. So how we can make square? If a parallelogram is there, to make it square, its adjacent sides must be equal. In the square, adjacent sides are equal. So we will start this. First, here it is given, diagonals of a square are equal and bisect each other. So it's given it's a square. Okay, diagonal of a square are equal and bisect each other at right angle. It's given square, so we need not to prove that sides are equal. We need to make the diagonals are equal. So we'll take this triangle and this triangle, this complete. So once read the question and try to find out which triangles to be taken. So here we will take triangle ADC and triangle BCD. So let's start out with the proof part now. In triangle ADC and triangle BCD. So I have taken this triangle and BCD. So here first one, AD is equal to BC. Can anyone respond how we got AD and AC equal? AD and BC? This is nothing but sides of square. Sides of squares are equal. So here they are sides of square. So they are equal. Now the second point, angle D is equal to angle C. This is also quite easy response, like how both angles are equal? Because it is a square. In square, each angle is 90. So here angles of square are 90. So the second reason. Third one, DC is common in both the triangles. So DC is common side. So this we will write common. So out of these two triangles, what we made? Opposite, these two sides are equal because they are sides of square. Angle D equal to angle C, each one is 90, third one is DC. So here DC is equal to DC, they are common. Now we got triangles 3 properties. So we can make the triangle to be congruent. So ADC is congruent to triangle BCD. By which property? Side, angle, side. So here we took this side, then we took this angle, one more side. So we'll make it to be equal by side, angle, side property. So this is SAS. Once the triangle is congruent, their corresponding parts will be equal. So here AC will be equal to BD by simplicity. This is nothing but diagonals of square. Therefore, diagonals of square, that is AC is equal to BD. This we proved. Now here, next one, we need to make they bisect each other. To bisect each other, we are going to take adjacent triangles. So take these two triangles now. Now for these two triangles case, here, so let's move out with that part. So once again, for your convenience, I'll draw it here close, so that when I'll start the solution, you will get the thing clearly. So it is, if I'll consider these two triangles, so what things you can use here? Already we know figure is square. So this one and this one, the sides will be equal. Second one, this is common side in both. And third one, here this side is common in both of them. And moreover, when we made this triangle and this triangle to be equal, so there we can make this angle and this angle to be equal. Here, see here, if we choose these two triangles first to make the diagonals bisect each other, so here this side and this side is equal, they're opposite sides or they're the sides of square. Then the next part, this angle and this angle, vertically opposite angle. And the previous case, when we made the complete triangle equal, there this angle and this angle can be considered equal by simplicity. So that three properties we are going to use here. So here only, when I made this triangle congruent, we'll add one more point, angle A equal to angle B. This is also by simplicity, which we are going to use in third property. Okay, third proof, second proof. So here in triangle, this is for the second proof where we need to make diagonals bisect each other. So that's we are starting now. In triangle AOD and triangle BOC, we have taken two triangles. First point here, AD is equal to BC. How AD and BC got equal? They are sides of square. In square, all the sides are equal. So here, make the statement like sides of square. Second point, already we proved angle A equal to angle B. So for this, we will write like proved above. Now for the third case, angle O is equal to angle O. This is nothing but vertically opposite angle. So once again, let's move out. Once again, I'm repeating, concentrate to get it clearly. We have taken these two triangles. In the previous case, when I took the complete big triangle, there I made angles to be 90. Diagonals we need to make equal. So from there, we made the diagonals equal. And one more point we used, angle A and angle B are equal by simplicity. So which we are going to use further. So that one I used over there to use in the next part. Now we have taken this smaller two opposite triangles. So here in the triangles, which properties we used? The first one, the sides are equal. They are sides of square. The second property, already angle A and B was made equal. So that same property we repeated. Third one, angle O and angle O are equal, which is nothing but vertically opposite angle. So here we made both the triangles to be congruent by two angles we used and one side. So we give the similarity criteria by AAS similarity. Now here the triangle made similar. when we made the here we made the triangle to be congruent. So AOD is congruent to triangle BOC. Once if the triangle is congruent, their corresponding parts will be equal. So what are the corresponding parts over here? Here we need to make diagonals equal. So we'll make OD is equal to OB. In the same way, OA is equal to OC. Therefore, OA is equal to OC. Diagonals are bisecting. So whatever the same diagonal is there, its parts has to be taken. OA is equal to OC. That is the first part we took. And the same way, OD is equal to OB. We need to cover this triangle first. So this side and then this we made equal. In the same way, out of this triangle, this side, that is OD equal to OB. So here, this we got by simplicity. So here we made it like diagonals bisect each other. So this was the second part which we need to make. If you read the question there, they have made to make three conditions to be equal. The first one, in true proof, we need to make diagonals equal. Second one, they bisect each other. This also we completed. We made the diagonals equal. We completed they bisect each other. Now we need to make the third part, that is they are right angle. Diagonals bisecting at right angle. So how you can make it they are bisecting at right angle? For that, we need to go for the adjacent triangles. We need to make adjacent triangles to be congruent. So here, if we make adjacent triangles congruent, we can go with these two angles. If we make that angles are equal, then we can prove it 90 by linear pair property. So that we need to move out with the third part. So let's move for the third part now. Now in the third part, so once again, if I draw the figure, you will get it clearly. So here, the figure was in this way. It's square and we need to make angles to be 90. Okay, so here in the figure it was A I took in the beginning. So here A, B, C, D. Okay, I started with here. So A, B, C, D. In this we need to make diagonals bisect each other at right angle. So third part we are proving now. So here in triangle AOD and triangle COD. AOD and COD. First part, out of the both triangles, the first one AD is equal to CD. Can you guess the reason why AD and CD are equal? They are the sides of square. So you will write sides of square. That's the reason. Second property which we are going to use, OD is common in them. OD is equal to OD. So it's common side. Third one, if you recall back, we made the diagonals equal. So OA is equal to OC. This is diagonals bisect each other, proved above. So this we already proved. We got 3 points here. Therefore, triangle AOD congruent to triangle COD. So this is how we got they are congruent? By SSS property. Once if we make the triangles to be congruent, their corresponding parts will be equal. So here, if I'll take this angle to be 1 and this angle to be 2, I can make, therefore, angle 1 is equal to angle 2 by simplicity. Once if the angles are equal, we can make them easily 90. So as the angles are equal, I'll consider both to get to be x. Let it be equal to x. Therefore, x plus x is 180. So how we got this to be 180? They are making linear pair. So here, reason is linear pair. Therefore, twice of x is 180. So x is 180 divided by 2. So it's 90. We got the value of x as 90. Now when we got x to be 90 in a square, like what we need to prove here, they asked for the 4 points, 3 points if you recall. They asked us to make the diagonals to be equal. So that by taking these two triangles, we made them congruent and we proved that diagonals are equal. For the second part, to make the diagonals bisect each other, we took two opposite triangles. These two triangles we took. And in that triangle, after making them congruent, we made that this part is equal to this part is equal to this part. So that the diagonals bisect each other. The third proof was we need to make them bisect each other at right angle. So for that I took the side two triangles. So this is what you need to remember. Here we are using the same concept of chapter number 7 which we did earlier, similarities only. And then adding the further that what we are adding over here, addition is like you need to remember the sequence, which three triangles to be, like which step to be followed after what, like first which triangles to be made congruent, then after that what to be added. So here totally we made the triangle to be congruent thrice, and finally we reached to our destination. So here we are making these two triangles congruent. After that we got angle to be 90. So this we got 90. So finally we will make the statement, therefore diagonals of square bisect each other at right angle. So thus it got completed. We completed with the next question. So this is our second question completed. Now question number 3. In question number 3, here it is given diagonal AC of parallelogram ABCD bisect angle A. Show that it will bisect angle C also. So here it is given ABCD is a parallelogram. This we are starting with question number 3. ABCD is a parallelogram where, okay, in the figure they started with here A, B, C, D. Already figure is given, so follow out that labeling. In figure ABCD, diagonal bisect angle A. So this is given, it is bisecting. We need to prove that it will bisect angle C. And moreover, ABCD is a rhombus. So what is the difference between square and rhombus? If they will ask us to make any figure to be rhombus, it's very easy. If a parallelogram is there, to make it rhombus, only we need to make adjacent sides are equal. If we prove that its adjacent sides are equal, we can say that it is a rhombus. To make it square is little complicated, where we need to make adjacent sides to be equal, along with that angle to be 90. That the difference between rhombus and square is, here all the four sides will be equal along with each angle to be 90. That figure is called square. But for adjacent, for rhombus, only four sides are equal. That's sufficient to make. Hope like those who are attending, they are understanding. If there will be comments along with that, I'll feel little energetic to explain. Now here, in this, let's move out with the given part. Here, in given it was ABCD is a parallelogram where AC bisect angle A. In parallelogram ABCD, AC bisect angle A. So this is the given part. And then to prove, what we need to prove? We need to prove that here AC, this is first one, AC bisect angle C. This we need to prove along with the ABCD is a rhombus. So these two things which we need to make. So let's move out with that. So here, as it is given, it is bisecting. ABCD is a parallelogram is given. We know that in parallelogram opposite angles are equal. So we can start out our proof from there. So let's move for the proof part. In parallelogram ABCD, angle A is equal to angle C. We know that opposite angles of parallelogram are equal. opposite angles of parallelogram are equal. Now, when angles are equal, we can make their halves to be equal. Complete angles are equal, so their half of angle B will be equal to half of angle C. Now here, complete angle was equal, so their halves are equal. If we'll write here 1, 2, 3 and 4. So in place of half, we can write like angle 2 is equal to angle 3, angle 1 equal to angle 4. So as we made it half, so here you can write like angle 1 is equal to angle 4, angle 3 is angle 2 is equal to angle 3, as they are the halves of the angles. So here when we made them to be equal 1 and 2, so therefore when angle 1 and 2 was equal itself, as the diagonal was bisecting each other, so here angle 1 and angle 2 we got equal. It was given AC bisect angle A. It was given. So this is one, this is second equation, this is third equation. From all the three we can combine and say like 3 and 4 are equal among themselves. Therefore angle 3 is equal to angle 4. When we made both the angles equal, so this will make like AC is bisecting angle C. Therefore AC bisect angle C. Now we completed with this part. So once when the AC is bisecting angle C, we can move for the third, next step, where we need to make ABCD to be rhombus. So as I told, like if you want to make ABCD to be rhombus, you need to make adjacent sides equal. So already we made angle equal. So from the figure, we are saying like this angle is equal to this angle is equal to this angle. Moreover, both the angles are equal. So if I'll take only one triangle, finally I can conclude that angle 1 and angle 3 are equal. So already we proved that angles are equal. If the angles are equal, it is making an isosceles triangle. So we can make the sides equal. These sides are nothing but adjacent sides of parallelogram. So parallelogram is a rhombus. In that way we can conclude it. So let's move out with that. So here in triangle ADC, angle 1 equal to angle 3. This is proved above. Already we used. Moreover, they are making isosceles triangle property. Therefore, AB, that is the sides AD is equal to DC. As the angle is equal, their adjacent sides are equal. AD equal to DC. Okay, that is adjacent side opposite to equal angle are equal. So once you made the side equal, they are nothing but adjacent sides. Therefore, ABCD is a rhombus. So how we got ABCD to be rhombus? Here you will write the reason like adjacent sides are equal. So this we completed with the part. So third question got completed. If really you are, those who are attending, if they are enjoying the explanation, please comment on the comment section so that I'll come to know, and then I'll continue with further explanation where we can go through with the remaining questions. Those who attended, thank you for watching. For more such clear-cut explanation, subscribe my channel so that you can get explanation, and try to have some comments. So if there will be if you're getting any confusion, if you'll send it in chat section, I'll feel little energetic to respond you. So where you can get the response. And if you are unclear with any of the chapter, please comment me. It's related to like 9th and 10th standard. I teach 9th and 10th standard science and maths. in any topic. If you have any difficulty, please comment me so that I will clarify that. So generally every day I take my live session in between 4:30 to 5:30. If you have any queries, please attend and try to respond, which will make me much more energetic to clarify that. So today's class I'm winding up. Thank you for watching.